So let me start with talking about what a knowledge graph is. So there's basically two types of elements inside of a knowledge graph. There are nodes, which represent people, places, and things, and relationships, which represent verbs or interactions between those people, places, and things. And the basic idea is that as you start adding more nodes and entities, as you start adding more data, you start filling out all these relationships and everything becomes interconnected, almost like a bunch of pre-joined data. Now, Aura Agent is built on top of knowledge graphs. Aura Agents is very interesting because it allows you to wrap a knowledge graph process from start to finish. You think about building something like an automobile. There's thousands of parts that go into that, coming from potentially tens or hundreds of different places. And by itself, if you were just to feed an AI all of that data and ask it what happens if there's a tariff that goes up in a certain country or you're out of a certain material, it's going to have a heck of a time trying to find all of that, right? And so a knowledge graph helps you map all that data and basically tells the AI how to navigate it. What Aura Agent does is it allows you to automate the process of taking that schema from that knowledge graph, turning it into a draft agent, letting you edit that very easily, creating all the tooling that you need through a low-code UI, and then deploying that in a secure way, either through REST or MCP. So we're going to go over an example of an HR talent agent where, it's very simple. Basically, you want this agent to be able to help you identify backfills, identify need for certain talent, make sure that the company's sort of ready to take on new AI projects. And what we're going to find is that if we just take our resumes and we give them to AI in a conventional way, even simple questions like just counting how many Python developers we have and just telling us what our talent distribution is going to be challenging. And we're going to get wrong answers and hallucinations. But by mapping all of that data with the knowledge graph layer, what we're going to see is that, sort of instantly we start to have our data model defined and help our AI navigate basically all of our data. And then we're going to get the right answers. And we're going to show how with the Aura Agent, we can then basically automatically structure an agent around that and then deploy it all within just a few minutes. The source data for our agent will be resumes in PDF form. Just using a standard agentic stack with vector-based RAG on the PDFs doesn't work. Simple questions about the number of Python developers results in incorrect counts, returning 9 when 28 is the correct answer. Asking about the talent distribution also results in incorrect metrics, since the agent can only do generic searches on portions of the data. We can fix this with Neo4j and Aura Agent. We'll begin by extracting entities from our resume into a simple Neo4j graph data model. All of the code for this entity extraction is also contained in the linked resources. Once extracted into Neo4j, we have a knowledge graph with a set of connected facts that help ground our agent. In fact, we can even use this knowledge graph to automatically draft an initial working Aura agent in minutes, complete with prompts and various tools for graph RAG, including graph query templates, text-to-query, and vector search. Now, when asking about the number of Python developers, the agent uses its context of the knowledge graph schema and use case to invoke the correct tool calls, getting an accurate answer of 28. We can continue to test and iterate the agent in the UI as needed. But once ready, we can deploy to securely hosted REST and MCP endpoints at the click of a button. This allows us to call Aura Agent remotely from any AI client, including Claude, as we can see here, asking again about the talent distribution and receiving a corrected, accurate answer. We can extend this even further, creating custom query templates for more advanced multi-hop graph pattern matching, to score similarities between people and answer backfilling type questions. Graph databases also make it easy to add data and extend your schema, enabling us to include additional structured data, for example, from an HR information system, to answer different types of collaboration and career path questions. Why is Aura Agent more capable than just a relational database? So I'd say this breaks down into two areas. There's a performance and an ability to query your data really well. And then the second area is about flexibility and growth. So for the first area, performance and querying your data. If you want to query and understand, well, like how did a tariff going up in one country, how's that going to affect the price of an end product? that could go through 6 to 10 or hundreds of different paths, right, to be able to arrive at that. And what a graph allows you to do is basically connect all of that instantly, right? Whereas in a relational model, that would be really difficult. And while I'm giving a complicated example with supply chain, we see it show up all the time in other domains. Security, IAM permissions, for example. Even things like talent and HR, understanding links between people's skills and the things they've worked on. Same with legal use cases, and also in pharmacology and healthcare and all these different places. This shows up where you have all these different entities, and before you know it, you're doing 5 or 6, 7 hops inside of a query. The second part, flexibility. So one of the great things about Aura Agent is it's built on top of Aura, which is Neo4j. Basically, it's a graph database. And so what ends up happening in the type of graph database we have, it's called a label property graph, is you can start adding different types of entities, which are effectively nodes, very easily and instantly connect them inside of the graph. Whereas inside of strongly typed relational database models, I say strongly typed loosely, but inside of sort of relational tables, that can be very hard. Sometimes you have to add different join tables or do other things when you're incorporating more data. And then that could lead to problems where you have to refactor your applications downstream. So that flexibility to be able to add and connect data very quickly allows you to pivot very fast, which is important in AI, and start adding more and more data sources, whether they come from structured or unstructured places. All right, so now you've seen the demo. If you want to learn more, you can go to our Aura Agent webpage. From there, there's links to other learning content, other resources, and get started materials, as well as other webinars and videos that will allow you to go into more depth.